Hi everyone, this is Dr. G. Ravindranath Reddy, working as Assistant Professor in MLR Institute of Technology, Hyderabad. So in this video, we are discussing numerical methods and integral transform course. In that course, we are looking at root finding techniques. So in that root finding techniques, we are going to discuss iteration method. So in this video, we will see what is iteration method and how to use this iteration method to find out the roots of the given equation, and we will take some examples and we will see how to apply this iteration method. So first we will take the procedure of iteration method here. So already we said that this iteration method is used to find out the root of that equation, which is of the form f of x is equal to 0. So first we have to consider two real numbers here. So if we take x0 and x1, if you substitute this x0 in the function f of x, you will get that value is equal to f of x0. And if that f of x0 have a positive sign, then follow the same procedure and substitute that x1 value in the function, you will get f of x1, and that f of x1 value will be a negative value. So like this, we have to consider two real numbers. If you substitute the two real numbers in the function, their function value must have opposite signs. So like this, we consider two real numbers and we will represent that real numbers as x0 and x1. So these two real numbers indicates that whatever the root you are going for, this f of x is equal to 0, that root lies in between the two real numbers x0 and x1. Okay, this is the first point we have to do. So first one is, take the function f of x is equal to 0, and by using this, take the two initial values x0 and two real numbers x0 and x1. If you substitute the two real numbers in the function, you will get f of x0 and f of x1. So this must have opposite signs. So whenever the function values have opposite signs, then we can conclude that the root lies between in these two real numbers. And the second one is, now what we have to do is, we have to convert this equation f of x is equal to 0. This is the given equation, and we have to convert that given equation in this form, x is equal to pi of x. So if you want to convert this one into this one, this pi of x has to satisfy one condition. That condition is modulus of pi dash of x. That value should be less than 1 in the two real numbers in the interval x0, x1. In this interval, if you take any point, any value in this interval, for all the values, this condition has to satisfy by this pi of x. Like that, we have to convert this f of x is equal to 0 in the form of x is equal to pi of x. Okay, after getting that pi of x value here, then we can take the approximations by using this standard formula. So xn is equal to pi of x suffix n minus 1. So whatever the value we got here. So here, suppose if you take n is equal to 1, if you take n is equal to 1, here you will get pi of x0 here. So now, in order to apply this iteration method, it is enough to get only one initial approximation. But at the beginning, we have considered two real numbers. So from these two real numbers, if you want to get this single approximation, you take the average of these two numbers, x0 plus x1 by 2. Whatever the value we get for this, you consider that value as x0, our initial approximation. So from this initial approximation, get the first approximation, second approximation by taking different values of n is equal to 1, 2, 3, 4 and so on. So you stop these approximations until we get our desired accuracy. Desired accuracy means, suppose if you are at the sixth approximation, so if the previous approximation, that is the fifth approximation value, so the fifth approximation value and the sixth approximation values must coincide here. Then at that case, we can stop our approximations and we can conclude that root of that equation here. This is the procedure. The important thing is finding the two real numbers and converting the f of x is equal to 0 in the form of x is equal to pi of x. That pi of x must satisfy this condition here. in that interval x0 comma x1. After that, you take this standard formula to find out the approximations by using iteration method. One by one, you substitute that x values what we got in the previous approximation, then we can get our present approximation value. So like this you proceed. At a certain approximation, the present approximation value coincide with its previous approximation value. Then we can stop at that case. Then we can conclude our required root of the given equation. So let us take one example, and for that example we will see how to apply this procedure using this iteration method here. So take this equation. So find the positive root of x power 4 minus x minus 10 is equal to 0. This is a polynomial equation, and we have to find out the positive root of that equation by using iteration method. Now by using this iteration method, we will see how to find out this root of that equation here. So in the previous slide, we have taken the initial approximations, that is in two real numbers. Follow the same procedure here. So this is our equation. F of x is equal to x power 4 minus x minus 10 is equal to 0. So from this you will get f of x value is equal to, this is our f of x power 4 minus x minus 10. Now by using this function, I want to find out the two real numbers. So I don't know what are the two real numbers satisfies this condition. So you start with x is equal to 0. So you will get f of 0 is equal to, x is equal to 0 means you will get only a constant term here, that is minus 10. Here we are having negative sign. Now you take x is equal to 1 here. Once again you substitute that x is equal to 1 in this function, you will get that value is equal to minus 10. Now then go for the next number, x is equal to 2. So if you substitute x is equal to 2 here, you will get 2 power 4 minus 2 minus 10. So 2 power 4, 2 2s are 4, 4 into 4 16 minus 12. So that is 4, which is a positive sign. So when we take x is equal to 2, this function value is positive. When we take x is equal to 1, this function value is negative sign. So for the two successive numbers, we got opposite signs. So we can conclude that whatever the root we are going to find out, that root lies between 1 and 2. Since f of 1 and f of 2 are of opposite signs. So since f of 1 and f of 2 are of opposite signs, then the root lies between 1 and 2. So these are the two real numbers here. So that is the first step here. This is our first point, first stage. Now the second stage is, we have to convert this f of x is equal to 0, this equation, in the form of x is equal to pi of x. So from this equation, if you want to convert in the form of x is equal to pi of x, we have many ways here. So that we will see what are that ways we are having. So first, if you take x square, x power 4 minus x minus 10 is equal to 0. So from this you send this minus x to this side. You will get x is equal to x power 4 minus 10. So this is also in the form of x is equal to pi of x. This is one way to get x is equal to pi of x form. So that's why we have taken the first one. Now second case, suppose you keep this x power 4 as it is, keep this first term as it is and send the remaining two terms to this side. So you will get x plus 10. Okay, so from this you want to take x is equal to, so you remove this power 4. So in order to remove this power 4, we have to apply the fourth root here. So you will get x plus 10 whole to the power of 1 by 4. This is another way to get the value of x is equal to pi of x. So this is the one way, and then we will go for the next way. So you send this constant term to the side, x power 4 minus x is equal to 10. From these two terms you take x common here, you will get x cube minus 1 is equal to 10. So from this you will get x is equal to 10 by x cube minus 1. So this is another way to get the function, to convert that function in the form of x is equal to pi of x. So these are the three cases we are having in the form of x is equal to pi of x. But these three cases, these three forms, we don't know which form satisfies this condition. This is our important point. So that is our point is, our condition is modulus of pi dash of x should be less than 1 in the interval. You consider the two real numbers, consider that in the interval 1 comma 2. So this, in this interval we have to check this condition. Suppose if you consider this one, this becomes the pi of x value, and find out that derivative, and you take any point in this, you substitute that in the pi dash of x, and that value should be less than 1. You take the another value in this interval, you check the condition, that value should be equal less than 1. So one by one, we don't know which one, which of the form satisfies this condition here. Now let us check one by one here. So first we are having x is equal to x power 4. The first form is x power 4 minus 10, x power 4 minus 10. So this is x is equal to pi of x form. So our pi of x is x power 4 minus 10. You find out the derivative. Pi dash of x is equal to 4 into x cube, and this derivative of constant is 0. So this is our pi dash of x. Now take the interval 1 comma 2. Now you can take any value in this. Suppose if you take 1.5, you substitute that 1.5 here. Pi dash of 1.5 is equal to 4 into 1.5 whole cube. So definitely this value is greater than 1. So at 1.5 this value, the condition is not satisfying, so we should not consider this form. So like this, one by one we have to take the conditions which we got in the previous slide. So next you take this and get the derivative of this pi of x, and substitute x is equal to 1 to 1, 1, 1.1, 1.3, like this. You substitute all the points, for all the points that this condition has to satisfy here. So out of all these forms, this is the only condition satisfies this condition here, modulus of pi dash of x less than 1. So whenever we are having a polynomial equation, then you first identify the highest degree term in that polynomial. From that highest degree term, whatever the value we get, whatever the form we get in the form of x is equal to pi of x, you consider this form, then definitely it will satisfy this condition here. So this is the highest degree term x power 4. You keep this term as it is and send the remaining terms to this side, and from this you get the x is equal to pi of x form. So this will satisfy for the given condition. So only out of these three forms, only this form x is equal to x plus 10 whole to the power of 1 by 4 satisfies our convergent criteria. This is our condition here. So now like this, we have to identify the suitable form which satisfies this condition from the different forms of x is equal to pi of x. This is the important thing here. So once if it is completed, most of the problem will be completed. So now we take the iteration formula. This is our standard formula we are having for the iteration method. Now one by one you substitute n is equal to 1 comma 2 comma 3 comma 4 and so on. So first we will take the initial approximation here. So we got the two real numbers 1 comma 2. So whenever we get two real numbers, from these two real numbers, if you want to get only one initial approximation, then you take the average of these two. So x naught is equal to 1 plus 2 by 2, we will get 1.5. So you consider this x naught is equal to 1.5, and then substitute that 1.5 in the function pi of x. So this is our pi of x here. So put x is equal to x naught, that is 1.5. So 1.5 plus 10 whole to the power of 1 by 4, we get 1.8415. Okay, now this is our x1. Now we are going to find out the second approximation. Second approximation, if you want to get the second approximation, take n is equal to 2 here. You will get x2 is equal to pi of x suffix 2 minus 1, that is x1. So substitute whatever the value we got for x1, you substitute that value in this function, you will get our x2 value here. So in place of x, we have taken x1 1.8415 plus 10 whole to the power of 1 by 4. We got this value. Follow the same procedure here for x3 also. x3 is equal to substitute that x value here and apply, simplify this. So here after decimal point 3 digits are coincident, so better to go for the next approximation. So in the x4, if you want to find out the x4 value, substitute the previous value x3 and calculate this, you will get 1.8556. So now I want to stop the problem here, because in the fourth approximation our x4 value and x3 value both are same. Whenever present approximation value and previous approximation value both are same, then we can conclude that this is our required root. So since the root is 1.8556, correct to 4 decimal places. So this is very simple iteration method. Using of iteration method and getting the required root is very simple, but here we must be very careful while you are converting x is equal to pi of x, and taking the value of x is very important here. In order to consider this pi of x value, then this pi of x has to satisfy this condition. Modulus of pi dash of x should be always less than 1 in the interval 1, 2, or in general we can consider x0, x1. So this is the way how we can apply this iteration method and how to get this required root for the given equation. So these are the methods we are having. So in the previous slides we have seen bijection method, Regla-Falsy method, Newton-Raphson method, and iteration method. So in our syllabus, these are the 4 methods you are having. With this, we can complete our root finding techniques to find out the root of the given equation. So in this session, we have discussed how to use this iteration method. With this iteration method, we have completed the root finding techniques we are having. And in the next video, we will discuss about the numerical integrations. So numerical integrations, what are the standard methods we are having to apply the integrations? What are the numerical methods we are having to apply the integrations? Suppose in the intermediate we have seen, or in the previous classes we have seen how to evaluate these definite integrals. So integral 0 to 2 1 by x into dx. So we can apply this integration. We have the standard formulas. By using that standard formulas, we can find out these integral values, and we can substitute that upper limit and lower limit. We will get some definite value here. This is very simple by using our standard formulas whenever the function is known. So now I have given one value 0 to 1 and asked to find out f of x dx. Then by using our standard formulas of integrations, then for unknown function it is not possible to find out that integral values. So whenever we are having these type of situations, or one more thing is, whenever our function inside the integration is more complicated to apply these integral formulas, in that case also we can go to the numerical methods. By using that numerical methods, we can find out the integral value for unknown functions as well as the complicated function to find out that integrals. So these things we will discuss in the next video. Thank you.